All right, so we're back. This should be the last video, and I got Windows 10 to pick up its IPv6 DHCP address, and the key actually was just I rebooted it. That's simply it. That when I set up for these videos, I went through and practiced all this just to get my notes squared away, and I didn't have to do that, but I this time I did. I rebooted it, and you're thinking, really, is that all you had to do? Honestly, that's all I had to do. I rebooted it. But an interesting thing here, I rebooted it. Let me finish my sentence. I rebooted it and it picked up an address. We'll go look at the server and you'll see that it picked up an address from the server. But if I go look here, I want you to notice that it didn't, where IPv4 started at the beginning, it started at like what we said, 110 to 199. It started at the beginning. It started giving out addresses. IPv6 didn't do that. It jumped in towards the upper end and gave out an address. So I just wanted you to see that. And we could also check connectivity here. So ping IPv6. Okay, and that all looks good. Let's go look at the server side of it. So on the server side, I already did this. I refreshed. So I hit F5, and there it is. Okay. So we're getting values now, both least values for Windows 10, both out of IPv4 and IPv6. And honestly, I simply rebooted it, but I almost forgot to show you something. And it's in the notes, but I almost forgot. And that's that we need to go to PF1, and we need to look at a setting on PF1. With IPv6, the router, which PF1 is our router, the router plays an important role. It does what's called router advertisements, and router advertisements are how IPv6 clients know where the default gateway is. And I want you to see where it's set. Now it happens to be set correctly, but I want you to see it just the same. So we go to services. There we go. DHCP server and router advertisements. pfSense can also be a DHCP server. It can be a lot of things. We're not using it for that. We're not using it for that at all. When we installed pfSense, it asked us if we wanted it to be a DHCP server, and we said no. We were going to have our own. Okay. So anyway, so I come here, and what you need to do, this is the gotcha here, is it defaults to the WAN interface. That's not the one we're interested in. We go to the LAN interface, and we go to router advertisements, and this is what we want. Assisted means that there is a DHCP server on the network. Now it gives a full long name here, and different vendors call this different things. Microsoft calls it managed and something else. Microsoft refers to it as M&O, managed and something else. They call them flags. This one calls them flags too, but it uses the word assisted, and then it gives a description. And what assisted means, is how pfSense interprets this, is assisted means that there's a DHCP server on the network, and that pfSense or router is just meant to give out default gateway information. So you can see the different choices here: disabled, router only, managed, unmanaged, and so on. Okay, but we want assisted. That's important. Even though it's set correctly, we don't have to change anything. That's very important. When you're working with deploying DHCP v6, this will be something that you have to stop and you have to go look at what terms does the vendor use. Microsoft, as I mentioned, uses the terms M&O. pfSense uses much more descriptive. They're calling it an RA flag. You have to look at what the terms the vendor uses. You have to read the descriptions, and what you're looking for is the setting that says that the router is just going to help out. It's not going to try to provide everything. It's not going to give out IPv6 addresses, which it could. This is an interesting thing, but router advertisements can give out everything except for a DNS server reference. So a router advertisement can give out an IPv6 address with a /64 prefix. It can give out a default gateway information, but it cannot give out DNS server values. What's assumed is that the router is a DNS proxy. That's assumed, which is an assumption. It's not often the case. Okay, and then you go look at the DHCP server side of it, and the DHCP server can give out everything except for where the default gateway is. And so it's just weird. Why can't now I'm being a little bit silly here, but why can't we get everything in one place? That's not my, I'm just being silly. The industry is not subject to why can't we do something. Okay, that's the way it is. All right, so we're done. Let me just do a quick review. So what we did was we checked that Server1. I'll just bring this over here. We checked that Server1, PF1, and Windows 10 were healthy. We did that up here. Said okay, verify that they're good to go. We did that. I went ahead and checkpointed them. I sure enough did, so that I have a way to revert back. I use that more than you would think, and I'm always take a moment to do that, because if things go wrong, at least I can get back to where I was. I then went into DNS, and I happened to install DNS and DHCP together. Often when we install roles, we don't. We install one at a time, and we configure them one at a time. But DNS and DHCP are so commonly deployed together that it's just almost habit to go ahead and add the roles together. And so I did that. No reboot was required. And then we jumped in and started creating our forward lookup zone named IP. Some of it got populated for us. Created the reverse zones, one for IPv4, one for IPv6. We said that they were all three primary, meaning that they're read-write. But we also said that they're not to allow dynamic updates, meaning that only us can go in and add information to them. Clients can't come in and populate information on their own. That's called dynamic DNS, and we're not allowing that. We then told Server1 to use itself for DNS, and that was using the loopback, the 127 value for IPv4, and ::1 for IPv6. And then we tested it. First of all, we went to the server and tested using the monitoring utility in the DNS server console. And then we went to NSLOOKUP, great tool. And then we went ahead and did one more. We just went ahead and opened a web browser, I mean, just as a final test, and it all looked good. It worked good. We then said, okay, everything's good to go. Let's go ahead and add our Windows 10 record, and that we did. Then we moved over to DHCP. And for DHCP, I had a note in here that we don't need it this week, but next week we're going to need these values, and that's for the reservation. So I went ahead and got those values off my Windows 10 machine. I'm not using them just yet, but I got them. And then I went in and I identified what I needed to do. I got my information, my ducks in a row. And you can see here that I went ahead and filled in my own information, but you'll have to fill in your own. So everywhere that was true, I put these underscores to say, hey, that's just me. So underscore there, Cancun underscore. And I had that information handy, and I went ahead and created the scope and did my options. This was part of the wizard. The wizard walked me right through all three of those, and that was good. Then I went to this IPv6 to do the same. And IPv6, what threw me off at first is it asked me for my network ID or prefix, but then the next screen was exclusions, and I was expecting that to be the leasable addresses, but it didn't ask me that at all. It just said, what don't you want to lease? And so it kind of threw me for a minute, and I had to, in my head, do the math on that. And I said, okay, I want to exclude up to 110, and I want to exclude after 199. And so after 199 took me all the way to FFFF. Okay. Then I went ahead and did my options. Now the wizard did not walk me through those options. I had to right click and say I wanted to do them myself. And again, I had those values and I went ahead and filled them in. And then I went over to Windows 10 to test it. I went to Windows 10 and I configured it from being a static address, which was needed up to this point, to a dynamic address, DHCP. And what I found was IPv4, it picked that address up right away, but it didn't seem to want to get an IPv6 address. I mean, it did get one because it actually did communicate, but it was getting it from the router. It wasn't getting it from Server1. So I had to troubleshoot that, and what I did was I just verified my values. I paused the video, verified my values, and rebooted Windows 10, came back and saw that it immediately picked up its DHCP address. We then said, hey, don't forget, go to PF1 or go to your router, whoever it is. It doesn't matter who it is. Routers today, they all do it. You just got to check and see what the router, and it's called a router advertisement. That everybody agrees on that. They call them router advertisements. And then what they don't agree on is this part here, whether it's assisted or managed, unmanaged, M flags, O flags. You have to read the description to decide. But what we wanted was we wanted the function of the router to not hand out addresses, but to just hand out who is the default gateway. So we did all that, and I'm good now. So what I'll do is I will re-checkpoint my virtuals as of that they're now configured with DNS and DHCP, and I'll remove my old checkpoint. Actually, I could even wait. I could run because it'll be a few days before we do the next video series. So I could remove with Windows Hyper-V. It is a preferred practice not to run your virtuals with checkpoints for a long period of time. So I'll go ahead and remove my checkpoints, and then I'll come back in prior to the next video and do the same thing. I'll come back up here to the top. I'll check the health of my machines. I'll checkpoint them, and then in our next series of videos, what we want to do is we want to get the reservation working. All right, so that's it. More than just a tutorial on how to do this, we also took the opportunity to learn a little bit. Hopefully you've got everything that you need. You do. You've got your book. Don't forget your book. Your book has chapters, modules on both of these topics. You've got the book, you've got these videos, you've got the notes. You can play with this. You can checkpoint, try, and retry. And that's the whole idea, is to get you some keyboard time to get real familiar with setting up DNS and DHCP. So I'll wrap this up, and we'll call this a package of videos, and we'll be ready then for moving forward with the project next week.